Okay, so today we're moving on to 4-8 complex numbers. Our objective is to identify, graph, and perform operations with complex numbers. That's what we're going to do today. So tomorrow we're going to learn to find complex number solutions of quadratic equations. Okay, so tomorrow we'll work on finding complex numbers solutions of quadratic equations. So today I want to focus on a couple of things. We're going to introduce what is an imaginary number. Well, an imaginary number is just this. Let me scroll this down. There we go. The whole basis of imaginary number says that when I square a number, we're going to call it a little lowercase I. That's going to stand for our imaginary number. When we square this number, whatever it is, we're going to get a -1. Okay, so what would it mean? Let's reverse this. Well, what if we take the square root? How do we clear this? How could we solve this for I? Take the square root of each side. And if those cancel out, I'm going to get that I is equal to radical of -1. We've been told all this time in Algebra 1 and up to now in Algebra 2. And I always quantify it with we up to this point, or as far as we know, we can't take the radical of a negative number. We can't square anything and get a negative number. But now we're going to introduce this little concept of an imaginary number that says whatever this little thing is, when I square it, I get a -1. Okay, so that's our new rule, and that's called an imaginary number. So the two things you need to remember is I squared equals -1. So when you are simplifying and you end up with like a 3i squared, well, what's that going to simplify to? It's going to simplify to I squared goes to -1 times 3. It's going to simplify to a -3. Okay, so the whole basis says I squared equals -1, and then the square root of -1 is equal to I. Okay, and that's the basis of all this stuff we're writing up here. So it says for any positive number a, the square root of -a is equal to -1 times a, which is radical of -1 times radical a. And we know the radical of -1 is just I, so it becomes I times radical a. So I just showed you an example a moment ago. Here's another one. So they have radical -5. Well, we know that that's going to be that negative sign. We can just pull it out. That becomes I, right? So I radical 5. And if you want to go to the process of put all the little intermediary steps in between, like that's going to be -1 times 5, and that's going to be radical -1 times radical 5, and radical of -1 is I. Oh, so my answer is I radical 5. You can do those steps every time, but that's pretty tedious. Once you understand how that works, basically when you see this, you can just pull it out and go, that's I radical 5. Okay? Any questions on that? We'll talk about this one in just a minute. Well, actually, I'll talk about it now. It says, note that radical -5, the whole thing squared. You might think that that's going to equal just a 5 because there's a -5 squared there. So you would think that's going to be 5. Let's break this down with our imaginary knowledge now. Well, what does this equal? This is going to equal radical of -1 times 5, and I'm going to do the little baby steps, squared, which is radical of -1 times radical 5 squared. Right? And we know that radical of -1 is just I. So now we have I radical 5 squared. And we can rewrite that as I squared radical 5 squared. Everyone agree? Because we're just distributing to both terms, the I and the radical 5. That's all algebra 1. The only thing algebra 2 is the I part, the imaginary part. Now, we know that I squared is equal to what? The first rule I gave you today, I squared equals, did you not write it in your notes? Thank you, -1. And then radical 5 squared is what? Okay, let's break it down. Radical 5 squared is radical 5 times radical 5. That's not a negative, that's my pen skipping. Okay, so what do we get when we square two things? That's the same as saying radical 5 times 5. Agree? And what is 5 times 5? 25. So what is radical 25? What is radical 25? 5. Okay, so whenever you see radical 5 squared, these things sort of cancel each other out, and it's just what's under there, the radicand, 5. So we get -1 times 5, which is -5. So be careful when you see the squared, when you're dealing with negatives, imaginary numbers under there, okay? Because you will revert back to, oh, -5 squared is going to be a positive. No, it's not. Okay, so be careful. And go through the math and prove that's going to be a -5. Okay? So these things like this, guys, this is pre-algebra. It's like 8th grade math. We've got to sharpen up our skills, okay? And the only way to do that is go through every single little stinky step on these things. Write them out, and you will get sharper and sharper and faster and better all the time. Okay, but if you're just not doing homework, you're going to stay right there. You're going to be stuck at knowing 7th grade math. And when you get progressed up to pre-calc next year, you aren't going to even know where to begin. So you've got to start doing all the homework, okay? And that's what will help you get better. And then go out and practice. Go to coolmath.com. It's just math games. Learn these little things. YouTube videos. Our videos. Pearson SuccessNet, right? Do all those things and make yourself better. Now the next thing I'm going to talk about is a conjugate. A conjugate is actually, because this is later in the lesson, I'm going to hold off on that for a minute. Let's put to use what we've just learned, okay? And I'll give you a moment in a little bit to copy those if you didn't finish, okay? So this is what I talked about. The imaginary unit is a complex number whose square is -1. I squared equals -1. So that's the basis of what we're doing today. And so that also means that radical of -1 equals I. These are the two things we'll be using today. That's what we just talked about. Okay, so let's look at problem 1. How do you write radical 18 using the imaginary unit I? So what we're going to do is start by saying, well, radical -18. And we know that by what we just talked about, that can come out here as an I. Right? So I radical 18. Well, we're not finished because that's not simplified, right? How can I simplify radical 18? Does that have a perfect square factor? What is its perfect square factor? So we've got 1 times 18. 2 times what? 9. 3 times 6, and then it reverses. We don't laugh at anyone, okay? We're a math family. Be nice. And then it reverses. Then it goes back to 6 times 3, because 4 doesn't go, 5 doesn't go, and then you're back to 6 times 3, 9 times 2, and 18 times 1. Which one of these factors of 18 are a perfect square of another number? Can I multiply something together and get 18? What's 1 times 1? What's 2 times 2? Here's our perfect squares. 1 squared is equal to 1. 2 squared equals 4. 3 squared equals what? 9. Do you see any of these so far in our factors over here? Do you see a 1? Well, 1 we don't use. Do you see a 4 or a 9 over here in our factors? Come on, guys. Yes, we've got a 9 right there. That's a perfect square. A perfect square of what? 3. So this is a perfect square factor in 18. So you've got to rewrite these in a perfect square factor. So it's going to be I times radical 9 times 2. Okay. So now we can split this up and say I radical 9 times radical 2. Agree? Same thing. Right? I just split this guy up into 2 radicals, which is the exact same thing. Now, what's the square root of 9? What times what equals 9? 3. So that simplifies to I times 3 times radical 2. Okay, now everything's in the most simple terms, but now we've got to put it back in the correct order. So just like you would do a coefficient and a variable and a radical, we're going to do the same thing here, except we're going to put the 3 first, the I second, and the radical last. And that's your answer. Okay? Any questions on that?
Y3.
Excuse me?
Y3 and
Y3?
yeah.
Okay. All right, so let me erase part of this. The question was, why is it 3? Okay. I'm just repeating for the video, though, because they won't be able to hear your voice, but they can hear mine. So when we say I times radical 9 times radical 2, we say, what is the square root of 9? It means what times what? What squared equals 9? So it means it's 3 times 3, right? And we know if we can multiply something, it shows up twice, we can take it out. Right? That's what square root is. What times what? What squared equals 9? That's what square root means. So this square root of 9 simplifies to 3. And if you still struggle with that concept, get a calculator. Okay. And I'm going to just keep going for the video's sake, though. So if you have standard, yeah, you want to go square root of 9. Whoops. On this calculator, we have to do the 9 first. So 9 square root, there it is, and it's 3. So when you have a square root of a number, it means what can I multiply to itself and get this radicand? Well, 3. So square root of 9 equals 3. So that's where the 3 came from. So we had I radical 9 times radical 2, and the radical 9 goes to 3. So we have 3 I radical 2. And there's your answer. Okay? Is everybody good? Questions are welcome. If you don't understand, don't hesitate to speak up. There's no wrong question. Okay. All right, let's move on to the next problem. Before we do, I want to talk about an imaginary number. An imaginary number is any number of the form of a plus bi, where a and b are real numbers and b cannot equal 0. So imaginary numbers and real numbers together make up a set of complex numbers. Okay, so an imaginary part is the I part. The real part of a complex number is the A part. So I could say the real part, this is a complex number because it has both real and imaginary numbers. And the real part is -3 and my imaginary part is 6i. Okay? So what about for this one? What's the real part? 3. And what's the imaginary part?
4i.
Or -4i. Okay? So everybody clear on that? These together make up a complex number. Think of, I use the example of a sports complex. When you think of a sports complex and you go inside, what do you see? What kind of sports? Do you see just one thing? Multiple sports. So it's many sports inside a complex. Think of complex number, many types of numbers. So for us today, it's just 2 of those. So you've got a real and imaginary. Those together make up a complex number, A plus BI. Now what happens if B is equal to 0? If I have 3 for my real part plus 0i, well, anything times 0 goes to 0. Well, I lose my imaginary part. I just end up with a real number. So I sort of lose the luster of an imaginary number. I'm sorry, of a complex number. Our imaginary part went away, so it's just a real number. So that's why they say B cannot equal 0, because you've got to keep that imaginary part in there. And here it is again. Complex numbers made up real parts and imaginary parts. The real is the A, the BI is your imaginary. Now, if your A is equal to 0, that's okay, because you just end up with a pure imaginary number. Because if A is 0, and let's say you get a 3i, well, you just end up with a pure imaginary number. The real part went away. They call those pure imaginaries. Right? And that's assuming that B cannot equal 0. Because if A is equal to 0 and B is equal to 0, you have nothing. You have 0. Okay? Any questions about that? Just a little concept, but all of this is easy. If you run into it, just working with it, you can recall and work with it because it's just algebra. Just remember, anything times 0 is 0. If something goes away, you're left with whatever's left over. The next thing I'm going to talk about is, let's see, your first 4 problems were like the ones we just worked on that first problem. 5, 6, 7, and 8 today, and you're just working the first page tonight, 1 through 14. But 5, 6, 7, and 8 are like this. It says, in a complex number plane, the point AB represents a complex number, A plus BI. So if they ask us to plot the complex number and to find its absolute value, well, let's think about what they're asking. On a complex number plane, oops. Let's see, this one? Nope. There we go. On a complex number plane, you have the real part. Let's say we've got 3 plus 2i. And they ask us to plot this number. Well, the horizontal axis now is our real part, our real axis. And the vertical axis, which used to be our y-axis, we call that the imaginary axis. Okay, and if we're going to plot this, we're going to go 3 on the real, 1, 2, 3, and up 2 on the I. And there it is. Easy peasy, right? So that point is just A, comma, B. Now, if they ask us for the absolute value, they're talking about how far from its origin did we travel. Really, it's this, from there to there, right? But how would we get that? So if we go over 3, let me get a different color. Over 3, I'm doing it in pink, and up 2. Well, doesn't that just create a right angle? And how could we find this hypotenuse? Pythagorean theorem, right? So to find this, all we have to say is this is the square root of a squared plus b squared. So when they ask you for the absolute value, well, it could be going this way, you know. So they ask the absolute value because it's a distance. So just know, when they ask you for the distance of one of these, it's just always going to be the square root of a squared plus b squared. That's all you have to remember. That's the absolute value of this distance, or of this complex number. So the distance ends up being square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. So this ends up being the square root of 13. That distance right there. Right? So plot the point AB, and then take square root of a squared plus b squared. And that's how you work these next 4 problems. And you've got these on your test also. So let's work some more. Then I'll take questions. So for the first one, it says, what are the graph and absolute value of each number? And the first one is -5 plus 3i. So that means we're going to go 5 units to the left because it's -5, and then 3 units up. So let's do that. And they did both of these problems on one graph, so there's 2. This one's in red, so go back 5 and up 3 and plot the number. There it is right there. And they've noted it, -5 plus 3i. So plot the number. Now they want the absolute value. So if a is -5 and b is 3, then it's going to be equal to the square root of a squared, which is -5 squared, plus b squared, which is 3 squared. So that's going to be the square root of 25 plus 9, which is the square root of 34. So the distance, the absolute value distance there, is radical 34. Any questions? It's really quite easy once you work through it and you're not just frantically trying to copy what I'm doing. So let's do another one. This one should be more familiar. Oh, now we just have a pure imaginary number, 6i. So that's our b value. So our a value must be equal to what? 0. Thank you. So if a is 0 and b is equal to 6, well, let's plot that. To plot it, we're not moving on our x-axis. We didn't move to the left or to the right because it's 0. And now we're just going to move up 6 from that origin. So up 5, 6, right there. Plot the point, and there's your 6i, 6 on the imaginary axis. Now let's get our absolute value. So it's going to be the square root of a squared, which is 0 squared, plus b squared, which is 6 squared. Well, that's going to be 0. 6 squared is what? 36. And what's the square root of 36? 6. So our answer for that distance right there is 6. And it makes sense, right? You could have just counted that out because it didn't tilt. We really didn't need the Pythagorean theorem to answer that. We could just count how many units did it go from the origin to the end. All right? questions? Hopefully it's starting to be familiar now. Okay, let's work B on our whiteboards. So I want you to do the same thing. I want you to give me the graph and the absolute value of, and I'll write it nice and big here, -3 minus 2i. Okay, so you're doing B. -3 minus 2i. So graph it and give me the absolute value of it. And I'm going to pause the video now. All right, so let's, everybody at once hold up your work and let's see what we've got. All right. I see a lot of you made your own graphs. It's cool. Don't forget you've got a graph on the back of that whiteboard too. All right, so don't erase. Now let's do it. Let's look up here together. So to graph this, we're going to go backwards 3, so to the left 3, and down 2. And there's the graph. Now to get the distance, oh, I'm sorry. It's not froze on the video, but it was froze on the whiteboard. Okay, we're good now? So there it is right there, the little pink.
It's still
Oh, how about now?
Yeah.
We're good? Sorry about that. All right, silly board is haunted. All right, so now we're going to get the absolute value, the distance. So now it's going to be the square root of a squared, which is -3 squared, plus b squared, which is -2 squared. So 3 squared, -3 squared is a +9, and -2 squared is a +4. So we have 9 plus 4, radical 9 plus 4 is going to be radical 13. So it's just coincidence that it came up the same. But you'll always get some kind of different answer there. All right. So this is how you do these. Are there any questions? Anybody not get this correct and you don't see how we got different answers? All right, wonderful. Let's move forward now. So now we've talked about how to tell what an imaginary number is, how to simplify very minor terms with the imaginary unit, negative square roots and such. And now we're going to take it a step further. We're going to learn how to add, subtract, multiply, and divide with our imaginary and complex numbers. So when you add or subtract complex numbers, what you're going to do is combine your real parts and then combine the imaginary parts. It's like terms. So your real parts is like one type of number and the imaginary parts are the other types of numbers. So let's look at our first example here. To add this, we've got two complex numbers, 4 minus 3i and plus -4 plus 3i. So when we add these, we've got to combine our real parts. So 4, it's a plus, so it's adding, -4. So we've got those two out of the way, 4 plus -4. There's my real part. And now let's do our imaginary parts. So plus -3i plus +3i. All right. So we've kept the terms together. The real terms stay together with the real terms, and the complex terms stay together with the complex terms. All right. Now let's add them. So 4 minus 4 is 0, and -3i plus 3i is also 0. So our answer comes out to 0. When you add something to a term and it causes it to go to 0, that's an additive inverse. So actually these two were additive inverses of each other, because 4 minus 4, 4 plus -4 is equal to 0. And -3i plus +3i also goes to 0. So because when we added this to our first complex number, that makes this the additive inverse of the first term, or the first complex number. Okay? just terminology, additive inverse is something that makes another term go to 0. Any questions on that one? All right, let's work another one. I'll work this one like I taught in Algebra 1. Anytime you're subtracting multiple terms inside parentheses, that creates a lot of room for error. The best thing to do is flip all the signs. So it's like distributing this -1 across everything and then just add, right? So let's do this. So I'll show you why it works to begin with. It's like taking -1 times -2 plus 4i. What does this become? So when you distribute a -1 across, this becomes a +2. And -1 times 4i is a -4i. So basically it flipped both of these signs. The -2 turned to 2 and the 4i turned to -4i. So that's why I do this. I like to get these signs out of the way so it becomes just an add. So distribute that 1 across and it flips all the signs and changes our minus to an add. And I've taught this since Algebra 1. And whenever you're subtracting any polynomial, that's a nice thing to do. And I promise you, you'll make fewer errors. Okay. Now, what we can do here is we could also do this in a columnar format. Last time I worked it out linear, just going across like this. Now we can work it out in a columnar way. So let's line things up by columns. So we'll keep a real column and an imaginary column. So we're adding, we're going to add, so our sign's accounted for. Now, +2 and -4i. Okay, so now just add them. So 5 plus 2 is 7, and -3i minus 4i is a -7i. So that's our answer, 7 minus 7i. And some of you might be thinking she is making way too big a deal out of just adding and subtracting these little things. I can just see that in my head. And if you're there, fantastic. All right, but you still have to show me you are doing the work, not just copying answers out of an answer key. All right? So show me you got this and you know what you're doing, okay? Any questions on that one? So I've shown you how to work it out in a linear format, and now I've shown you how to work it out in a columnar format. So whatever way is easiest for you, use that. All right, now we're going to multiply and divide complex numbers. So here's our multiply one. What is each product? Actually, I wrote it bigger over here. So we're going to multiply these. Now this one, you've got a monomial times a binomial. So in this case, we're just going to distribute the 3i across both terms. So let's do that. 3i times -5 is -15i, and 3i times +2i becomes positive. Let's break it down. 3 times 2 is 6, and I times I is I squared. Uh-oh, remember at the beginning, I said we can simplify that. Anywhere you have an I squared, we change that to what? -1. I squared is equal to -1. That's how we started the lesson today. So it's 15i plus 6 times -1. Well, let's simplify that. 6 times -1 is -6. So we have -15i minus 6. Well, that's not in its proper form yet. Let's get rid of that. And we can rewrite this as -6 minus 15i. Now it's in its simplest form. That's correct. That's the real part and the imaginary part. That's a true complex number. Any questions on that one? Don't forget, anytime you see an I squared, it's not simplified. You got to change that to a -1 and keep simplifying. All right, let's look at the next one. Oh, now we've got a binomial times a binomial, or a complex number times a complex number. So now we're going to have to use the FOIL method. So first is 4 times negative 1, that's negative 4. Outside is 4 times negative 2i, that's going to be negative 8i. Inside, 3i times negative 1 is negative 3i. And last is 3i times negative 2i, so it's going to be a negative 6i squared. Get in the habit of any time you write I squared, put it in parentheses to remind you, oh yeah, that's just negative 1. And what is negative 6 times negative 1? It's a positive 6. Now let's combine our like terms. Negative 4 plus 6 is going to be a 2. And now negative 8i minus 3, or plus negative 3i, is excuse me, negative 11i. And that's our answer. Any questions on that one? All right. Let's look at the next one. Oh, this is an additive inverse. This is what we talked about at the beginning. We've got A plus B times A minus B. What were those called? Complex conjugates? Well, let's work it out the long way first and see what we get. But just recognize this is a complex conjugate. We've got A plus B times A minus B. We'll do it the long way, and then we'll do the shortcut. And after we do that, from then now on, if you recognize a complex conjugate, you can just do the shortcut. So let's do it. Let's FOIL it out. Negative 6 times negative 6 is a positive 36. Negative 6 times negative I is a positive 6i. I times negative 6 is negative 6i. And I times negative I is negative I squared. Oh, there we go. There's that I squared again. So we rewrite that as a negative 1. Well, negative times negative 1 is a positive 1. Now we've got 36 plus 1, which is 37. So those are gone. And then 6i minus 6i goes to 0. So our answer is 37. Everybody see that? So our I terms went away. We're just left with a real number. Now, that was the long way to FOIL it out. Now, let's look at the shortcut, the rule for the complex conjugates. If I can find it. No. It's probably on the slide after the one I just had. Okay, here it is. Complex conjugate. If you get A plus BI times A minus BI, then your answer is just going to be what? A squared plus B squared. Okay, so let's go back. There it is. We said, we did it the long way, and we said it was square root of 37, right? Now let's erase all that and do it with the rule. We say if you multiply the complex conjugate, your rule is just going to be what? A squared plus B squared. So let's do it. A is negative 6, and B is understood to be 1, right? So it's going to be A squared, negative 6 squared, plus 1 squared. Well, that's going to be a 36 plus 1. Whoops. Square root. And that's going to be radical 37. No, there was no radical in that. I'm sorry. It's just 37. And there's no radical. Take that out. Ah. So it's a squared plus b squared. So that's why I was pausing. I was thinking like, no, there's no radical. So my mistake. Sorry. Negative 6 squared plus 1 squared. All right, so it's going to be 36 plus 1, which is 37. Okay? Any questions there? Sorry about my ear. Got the worst headache, so I get weird and make mistakes, so I apologize. All right. Oh, there it was. That's what I was looking for right there. So there it is. A squared plus b squared. No radical sign. Okay, the last thing is how do we clear fractions? If you've got an imaginary number in a denominator, it is not simplified. You cannot have a simplified answer if I is still in your denominator. Here we've got 3i. So we've got to fix this, right? So how do we do it? Well, when you want to clear the denominator, we're going to have to multiply by its complex conjugate. Okay, I wanted to show all of it, but I'll just show the next step. So I'm going to show two problems at once. Here's A, where we've got a binomial or a complex number divided by an imaginary number. And B, we've got a complex number divided by a complex number. So, well, what's the complex conjugate of 3i? It means what can I add to it? And it goes to 0. Negative 3i. So you're going to multiply by negative 3i over negative 3i. Because in essence, we're just multiplying this by 1. Not changing any value, we're just changing the way we represent it. And we're making that fit our needs, which is to help us clear that denominator. Right? So let's look over on the right. So the complex conjugate, remember, we've got a minus b, so it's going to be a plus b. So it's going to be 1 plus 4i. And again, we're just multiplying by 1, so it's going to be 1 plus 4i over 1 plus 4i. All right, let's look at and from here it's just the number crunching. From here you've got this. The only new thing was knowing how to clear that denominator, and I've already hit that step. Okay, so now let's continue. Let's work on the left side first. So now we're going to get, let me clear all that. So negative 3i, you're just going to distribute that across like we did in multiplication. So it's going to be negative 27i minus minus 36i squared. And then 3i times negative 3i is negative 9i squared. Oh, now it should come into light. Why did we multiply by the conjugate? Or the additive inverse, excuse me. So here we get negative 9i squared. Well, I squared is what? Negative 1. Negative 9 times 1. Negative 1 is a positive 9. So now we also have an I squared up on the numerator, so turn that to negative 1, and it turns your 36 to a positive 36. So we have negative 27i plus 36 over 9. And when you put that in the correct order, it's 36 first, minus 27i over 9. But you can still see that 9 goes evenly into 36, and it goes evenly into 27, so continue to simplify. And that becomes 4 minus 3i. So that's the answer over on the left. And now let's look on the right. Let's do this number crunch over here. So when you multiply by the complex conjugate, you get a squared plus b squared, which is going to be what? a squared is 1, b squared is 16. So really, you don't even have to go through that. You can just go straight to 17. Right? And then on the top, you're going to have to FOIL those out. Clear your I squareds. And when you do, you end up with negative 10 plus 11i over 17. Now notice, like here and even on the test, your answers are going to be split up. So if you've got this complex number over one monomial, they're going to split it up as negative 10 over 17 plus 11i over 17. But they don't write it like this. They're going to go 11/17 I. Okay? And that's everything today, guys. And I know that went fast. We've got 3 minutes, so go ahead and put up. Thank you very much. And tonight your assignment is 1 through 14 on 4-8. And we'll solve tomorrow, and that will conclude our chapter. Thank you.